over a king. 4 over 52. Is there a card that is both an ace and a king at the same time? No, there isn't. So you can look at it two ways. You can say, well, there's 0 cards out of 12 in the way that we looked at the prior example that I erased, 0 over that number, 0 over 52, sorry. Or you can simply go and think of this as, you know what, that is impossible, so that likelihood is 0. Okay? Whatever you like. What's the answer now? 8 over what? 52. What does that reduce to? 2 over 13. Nice. Okay, let me give you a definition. We say list A and B are mutually exclusive if the intersection of A and B is empty. Okay. Can you guys tell me? We have 2 examples. There were lists here. Which example can you cite or point to that satisfies this definition of being mutually exclusive? Which one? The list of, oh, you're saying what here? The list of aces and the list of kings are, no, the list of aces. In other words, you guys said, oh, this situation. The list of aces and the list of kings. What's their intersection? Nope. Intersection isn't 0. The intersection is what, Moshe? Empty. Outstanding. This is the intersection. Right? It's, what is this a picture of? The empty set. So if I list all my aces, I list all my kings, their intersection's empty. What that means is the list of aces and kings are mutually exclusive. Mutually exclusive. There's not a single item that's on both lists. Just like if I took the roster of this class, all the boys, men, and all the women, those 2 lists would be what? Mutually exclusive. There's not a single person that's on both lists. Okay. Remember, this is not biology, it's math. Okay, excuse me, let me close this. Eddie, you getting all this crazy? Always have to fight, always. Even for this stuff. Better get used to it. It's only going to get worse, not better. Okay. You guys okay with this idea? Yeah. All right, now I got a few options here. You want to take a break? All right. Let me get my, we'll take a nice, what? Hour? What are you going to do, go take a nap? We'll give you a 15-minute break, be back at 10:32. All right, we'll give you a few extra minutes, back at 10:35. Know one thing too. Oh yeah. Okay, can I erase all this stuff here? Let me erase this. Go to the second warm-up problem, because there's a few concepts to discuss here. All right, let's see. This is a very interesting table. It's a Titanic mortality table. And so once again, notice that you are selecting a passenger, meaning what? One passenger at random. And then you have a bunch of probability questions. Now recall, probability is counting. Is that true? So, for example, I have to know what the total number of passengers were on the Titanic. I have to know how much is in the sample, how many people were there. So how do I find that out? Have to add, is that true? So what do I add, though? I can add all the survivors, of which there was 332 men, 318 women, 29 boys, and 27 girls. This is the number of people that survived. What's that total? 706. Good. 700. You guys know there were 706 survivors aboard the Titanic? You assume that no one survived. Is that right? But there were over 700 survivors on the Titanic. How many people did not survive? Notice my language. Not survived. 1,360 men did not survive. 104 women did not survive. 35 boys and 18 girls did not survive. What's that total? What is it? 1,517. Now, if you take the number of survivors and the number of non-survivors, what does that equal? 2,223. Notice this. If I simply added the number of men that were on the Titanic with the number of women and the number of boys and the number of girls, wouldn't I get the same total? Well, let's see. How many men are on the Titanic? 1,600 and how many women? 422. How many boys are on the Titanic? 64. And girls? 45. Is it true that when I add these values, the sum is 2,223? Yes. Okay. So let's answer the first question. What's the probability that somebody what? Survived. Well, determine the number of survivors over the total in the sample space. How many survivors were there? 706 out of how many passengers? 2,223. Approximate this value to the nearest thousandths as a decimal. What do you get? 0. What? 318, right? That's the probability. What does this mean as a percent? 31.8 what? Percent of the passengers survived. They survived. Okay? You guys okay with that? All right, what's the next question? Non-survivors. Okay. What does it mean not to be a survivor? Well, you're a non-survivor. Okay. Well, let's see. How do you count the number of non-survivors? We already did. How many is there? 1,517 out of 2,223. What is that as a